Hello everyone and welcome to the video on large language models. Large language models are basically very advanced artificial intelligence systems that can process and generate massive amounts of text data. They are designed to learn from and understand natural human language and can be used to perform a wide range of language related tasks such as translation, speech recognition, and automatic summary generation. One of the key advantages of large language models is their ability to learn from vast amounts of data, which allows them to generate highly accurate and realistic responses to complex natural language prompts. Additionally, they can be trained on multiple languages simultaneously, which means they can be used to perform language translation between different pairs of languages, making them an invaluable tool for businesses and organizations that work with people from diverse cultural backgrounds. Not just language-related tasks, but LLMs can also have the potential to revolutionize fields such as research, science, and healthcare. By allowing researchers to quickly analyze and process vast amounts of complex text data, they can accelerate progress in areas such as drug discovery, healthcare diagnostics, and AI development. That being said, large language models also present some challenges. For instance, they require a significant amount of compute resources, which can be prohibitively expensive for some organizations. Additionally, because they are trained on huge amounts of data, they may inadvertently reinforce biased or discriminatory patterns in language use, which is something that researchers and engineers are continuously working to address. Overall, large language models are an exciting and rapidly developing field with tremendous potential to transform the way we live, work, and communicate. In this video, we will cover topics like what are large language models. After that, we will look at what large language models used for, and after that we'll cover how are large language models trained. After this, we'll look at how do large language models work, and at the last we'll see some applications of large language models. So without any further ado, let's get started. So we'll start with what are the large language models. Large language models such as GPT-3, Generative Pre-trained Transformer 3 are advanced artificial intelligence systems designed to understand and generate human-like text. These models are built using deep learning techniques and have been trained on vast amounts of text data from the internet. These models use self-attention mechanisms to analyze the relationships between words or tokens in a text, enabling them to capture contextual information and generate coherent responses. These models use self-attention mechanisms to analyze the relationship between different words or tokens in a text, enabling them to capture contextual information and generate coherent responses. These models have significant implications for a wide range of applications, including virtual assistants, chatbots, content generation, language translation, and aiding in research and decision-making processes. Their ability to generate coherent and contextually appropriate text has led to advancement in natural language understanding and human-computer interaction. Now we'll see what are language models used for. So large language models are utilized in scenarios where there is limited or no domain-specific data available for training. These scenarios include both few-shot and zero-shot learning approaches, which rely on the model's strong inductive bias and its capability to derive meaningful representations from a small amount of data or even no data at all. Now, we'll see how are large language models trained. Large language models typically undergo pre-training on a broad, all-encompassing dataset that shares statistical similarities with the dataset specific to the target task. The objective of pre-training is to enable the model to acquire high-level features that can later be applied during the fine-tuning phase for specific tasks. And the training process of a large language model involves several steps. The first is text pre-processing. The textual data is transformed into a numerical representation that can be effectively processed by the model. This conversion may involve techniques like tokenization, encoding, and creating input sequences. The next we have is random parameter initialization. The model's parameters are initialized randomly before the training process begins. The next is inputting numerical data. The numerical representation of text data is fed into the model for processing. The model's architecture, typically based on transformers, allows it to capture the contextual relationships between the words and tokens in the text. And the next is loss function calculation. A loss function is employed to measure the discrepancy between the model's predictions and the actual next word or token in a sentence. The model aims to minimize this loss during training. And the next is parameter optimization. The model's parameters are adjusted through optimization techniques such as gradient descent to reduce the loss. This involves calculating gradients and updating the parameters accordingly, gradually improving the model's performance. And the next is iterative training. The training process is repeated over multiple iterations or epochs until the model's outputs achieve a satisfactory level of accuracy on the given task or dataset. By following this training process, large language models learn to capture linguistic patterns, understand context, and generate coherent responses, enabling them to excel at a wide range of language-related tasks. And now, we will see how do large language models work. So large language models leverage deep neural networks to generate outputs based on patterns learned from the training data. Typically, a large language model adopts a transformer architecture which enables the model to identify relationships between words in a sentence irrespective of the position in the sequence. In contrast to recurrent neural networks, that is RNNs, that rely on recurrence to capture token relationships, transformer neural networks employ self-attention as their primary mechanism. Self-attention calculates attention scores that determines the importance of each token with respect to other tokens in the text sequence, facilitating the modeling of intricate relationships within the data. Now we'll see applications of large language models. Large language models have a wide range of applications across various domains. And here are some notable applications. The first one is natural language processing. Large language models are used to improve natural language understanding tasks such as sentiment analysis, named entity recognition, text classification, and language modeling. The next is chatbots and virtual assistants. Large language models power conversational agents, chatbots, and virtual assistants, providing more interactive and human-like interactions with users. And the next is machine translation. Large language models have been used for automatic language translation, enabling the translation of text between different languages with improved accuracy. And the next we have is sentiment analysis. Large language models can analyze and classify the sentiment or emotion expressed in a piece of text, which is valuable for market research, brand monitoring, and social media analysis. And the next we have is content recommendation. These models can be employed to provide personalized content recommendations, enhancing user experience and engagement on platforms such as news websites or streaming services. These applications highlight the versatility and potential impact of large language models in various domains, improving language understanding, automation, and interaction between humans and computers. And with that, we've reached the end of this tutorial. If you have any questions, please feel free to comment and we'll have it answered for you as soon as possible. Until next time, thank you for watching, stay safe, keep learning, and get ahead.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts, choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.